12.6 Using pointer expressions. So far, I explained many concepts. The gist of all of them is very simple. With reference to our previous example, so far we have been using V. If you declare a pointer for this, instead of using V, you can use star PV. Very simple. But before using star PV, you have to implement several other formalities like initializing pointer. More specifically, you must initialize the pointer. Then you are eligible to use star PV instead of V. What is the advantage? Already I told you. V is direct to you. V is indirect to processor. Actually, processor has to process our data. So V is direct to you and V is indirect to the processor. And star PV means value stored at the address PV is a direct notation to the processor, and with the minimum role of compiler, processor can understand like an address, and it is an indirect notation for us. Now, in two programs, I am going to show instead of V, how can you use star PV? Use PV or star PV or V to get the same result. Suppose, let us take a room's area. Room area is equal to L into B. That you know. This is a direct notation. Now, once you declare pointer variables of this, if you initialize pointer variable, for area, which formula I can write? Star PL into star PV. By this, you must understand that this is an efficient notation. I cannot prove it. The basic reason is our programs are executed within seconds. So, I cannot show you the difference, how many microseconds it is faster and all that. But you must believe this, and by this is a direct notation, and you can get the area. After initializing corresponding pointer variables, you can use star PL into star PB, then also you get the same result. And in 12.7 and 12.8, I am going to introduce this point, and by this, the program efficiency is increased. And one more thing I have to tell you, in the preprocessor chapter and earlier in third chapter also, I explained parameterized macros. Here in this program, I have applied parameterized macros. One thing you remember, whatever concepts you learn, it is not just ornamental. That knowledge you have to apply somewhere. So, parameterized macro, little complex concept. It is a combination of macro and functions. Now you understood macros, you understood functions. This is the right place where you can use it. And once again, I explained it to you. Don't worry about that. Now you see, first understand the problem. A cylinder radius is 5 centimeters and height is 10. A radius 5, height 10. And another cylinder's radius double of the first one. Let us name it as R2. It is double of the first one, and its height is 3 times. Height 2 is 3 times of the height 1. Height 1. Evaluate CSA, TSA, curved surface area, total surface area, and volume of two cylinders using pointer expressions and parameterized macros also. This is the problem. Now, all that, whatever you learnt and all that, now we apply. Only here, small change I am making. Actually, if you do not know pointer expressions and all that, in the formula, let us say, taking curved surface area, what you take? 2 pi r h. This formula used. Now what you use, where you are using R, you use pointer notation. Let us take R1, H1. Use corresponding pointer notation, H1 also corresponding pointer notation, and you get the same result. Now carefully observe. Only let us take one. For everything procedure is same. Let us take one. Now 12th line. Now let us consider the 12th line and the corresponding all code. Let us study. And R1 is 5.0, H1 is 10.0. Next, what you are doing, you created all the, you have written all the corresponding code regarding creating pointers. You initialize the pointers. Where you initialize the pointers, PR1, actually 19th line you see, 19th line what you are doing, PR1 is equal to and R1. In the same way, PH1 is equal to and H1. So initialization of pointer is also over. Then what you are doing, how to apply this? And now CSA, curved surface area 1, because there are two cylinders, the first cylinder. Now CSA, this is parameter, calling of parameter macro. Now what we are passing, star PR1 star PH1. Just you understand this. Now this is the curved surface area of the first cylinder. Now we are calling corresponding parameter is macro. Parameter is macro is nothing but macro and a function. This is like a function call. CSA PR1 PH1 star PR1 star PH1 you are passing. Where they go? Where they go? Just you see 6th line. CSA RH. These are like formal arguments. And what formula you have written? You have written 2 into pi into R into H. Formula I have written. Now you see that. See how it is evaluated. PR1. PR1's value is, you know that, this is nothing but R1. PH1, RU is nothing but 10.0. Now 5.0 is copied into R and 10.0 is copied into H. Thereafter, they are assigned here and it is evaluated. It is evaluated to CSA 314. See the output 15. Then where it goes? Then this value, the evaluated value goes here and it is stored in CSA1. It is stored in CSA1 and that is written. First understand, whenever multiple elements are there, don't concentrate on all the elements at a time. By that you never learn anything. Take one, or here actually CSA, TSA, volume 3 are there for 2 cylinders, totally 6 are there. 6 procedure is one and same. Then first thing is you crystallize your knowledge. In order to crystallize your knowledge and get command over this, the modus operandi of this, concentrate on only one. Now R1 is this, H1 is this. Thereafter I explained how to create pointer notations. Thereafter PR1 is created. PR1 is created and PR1, PH1 is created. Now this is the calling of parameter macro. CSA PR star PR1, that means value stored at PR1 and value stored at the address PH1. Then these values are assigned to formal arguments R and H and they are passed to the formula and this value is evaluated and it is passed to the calling statement and it is stored in CSA. When you wrote CSA, you got the result. Now In the same manner, after understanding this, you study the same concept for TSA, for cylinder 1, volume cylinder 1. Thereafter, with reference to cylinder 2, CSA, TSA, volume also, all the corresponding code you study, then close the book and write the same program on your own. If you are able to apply the same concept in other programs like room area, rooms floor area, four walls area, like that you can apply. Now many domains are around you only. You can easily, you know that in the school days only you learned all the arithmetics. So you take room, floor area, four walls area, like that same way you create after using pointer notations. By this, you can crystallize your knowledge. Just simply theoretically, if you study, all this is evaporated. Nothing is the residual. Only by application, you can digest this concept, and further, it is a weapon in your armory, and whenever you want, you can use it. Here you see, seventh line, we have declared two variables, A and B. A is 10, B is 5, integer type variables. Corresponding pointers we declared, and we initialize pointer variables in the 9th and 10th line. That is initialization of pointer variables. Now we are eligible to use pointer notations. Here all arithmetical operations we are performing. Simple thing. Only thing is, in order to give exercise to you and enable you to crystallize your knowledge, I have given this program, and you see that now normally we have to use A plus B. Now after creating the corresponding pointer, we are able to use PA plus star PA plus star PB and get the same result, and A plus star PB also you get the same result, star PA plus B also you get the same result. In the same way, you can apply not only plus, minus, multiplication, division, all that you get the same result. That is the basic objective of this program. You study entire thing and realize that, then you can realize that A star PA is an alias of A, star PB is alias of B. So, in one line, if we have to explain what we have learned so far in this chapter, means we are able to create an alias to an ordinary variable. This is the ordinary variable. This is an alias to that. So why we are creating alias? The efficiency of the program is improved, because how efficiency is increased? Compiler's role is reduced. Compiler is creating overhead in translation. So compiler's role is reduced. That's why efficiency of the program is obviously increased. So thoroughly understand the two programs, 12.7 and 12.8. Then whatever we learned so far in pointer chapter, you are able to crystallize that knowledge. That is very essential. Already explained to you one concept. This is the strategy. Whatever you learn, then you crystallize that. That's what I call temple steps approach. Learn something, and this is a platform, and you crystallize your knowledge, then go ahead. This is the strategy always we follow. And one thing, earlier also I explained, don't try to study many concepts at a time. For an average student, 5 concepts. Every time, average basis, 5 concepts you study. First, view the video. Thereafter, read the book. Thereafter, whatever programs are there, then and there you complete. Then, regarding the 5 concepts, that is the first and last day. In this way, there are totally 300 concepts. Every stage, you crystallize. This is the thing. You crystallize your knowledge here, and then proceed. Next, take 5. This is the strategy. It works out very well, and at the end of that, you get enormous confidence that as that you have been working on this thing for years long. So this strategy, within 1 or 2 months, you can master the language. And one thing, there is no end of this thing, but you are laying such a foundation, and by studying C language, indirectly you are studying advanced languages also. It contributes around 50% to the advanced languages, and at that point always you remember